What's up, guys? This is Alan from NoDullMoments.com, and today I'm going to talk about VLANs. Let's start off with a question of what is a VLAN? VLAN stands for Virtual Local Area Network, and it does exactly what it sounds like. It separates computers on one hardware network into different software-based networks. It basically separates the traffic on the two networks from each other on a software level. So if I had 4 computers and I wanted 2 of them to be able to see each other without seeing the other 2 and vice versa, I could set up 2 different VLANs to do that. Let's use VLANs 10 and 20. Now, according to 802.1 standards, you have to name these VLANs. For argument's sake and to make things easier, we'll name these customer and vendor. We don't want customers seeing vendors' data and we don't want vendors seeing customers' data, so we'll separate the 2. Now here's a part where a lot of beginners get confused. When setting up VLANs on managed switches, what's the difference between tagged and untagged ports? To help you understand things a little bit better, let's use Cisco terminology as well. Cisco calls these access and trunk ports. You can think of an access port or an untagged port as a port on your switch that you plug a device into that gives it access to the network on that VLAN. An access port is one that you would plug anything that isn't VLAN aware into, something like a computer or a server. If you aren't sure if your device is VLAN aware, even after reading its documentation, it probably isn't. A trunk port, or tagged port, is a port that basically connects your network equipment together on that VLAN. Tagged ports are used either with VLAN aware equipment or on uplink ports, the ports that go from one switch to another. That might sound a little confusing, but I'll keep going with my example. You'll get it in a minute. Something to keep in mind, by default, most managed switches have VLAN 1 untagged on all ports. That way, all traffic can pass where it needs to with little or no configuration. Something else to keep in mind is that you can have one physical port tagged with multiple VLANs, but it can only be untagged as one VLAN. So let's get back to our customer and vendor network. Remember that we have 4 computers. 2 are used by customers and 2 are used by vendors. We don't want them to see each other, so we're going to set them up on different VLANs. Here's our 8-port switch. We have 8 regular ports and 2 extras over here. These extras are usually gigabit, unless of course the whole switch is gigabit, and are generally used to uplink to the other switches on your network. So now we're going to plug all 4 computers into this one switch and plug in our uplink, and we'll pretend that goes to a DHCP server. Now keep in mind, since computers are not VLAN aware, we have to untag these ports. And since we're going to keep them on 2 different VLANs, we're going to untag these 2 on VLAN 10 and untag the other 2 on VLAN 20. As of right now, these 4 computers won't be able to get to the DHCP server. That's because we still haven't given our uplink port access to either VLAN. Now, since this port 10 over here is our uplink port, we need to tag both VLANs on it. We can't untag them because you can only untag one VLAN per physical port. And if we were to only tag VLAN 10, then just the customer computers would be able to access the DHCP server. The vendor computers would still be sitting there with a 169 address. Now traffic can flow freely between the computers and the DHCP server on the 2 networks. If you have a VLAN-aware DHCP server too, you can even set these up on different subnets. That's about all for my basics of VLAN explanation. If you have any questions or concerns, let me know in the comments. And again, this is Alan from NoDullMoments.com.